Hi, I'm Steve. You can call me Steve. This week's video comes in the form of a viewer question. Nan McG asks, when we're told that the freezing point of water is 0 Celsius or 32 Fahrenheit, how fast does that happen? If it's not instantly, how did scientists know that it's 0 and not -1 or +1 or something similar? I'm going to answer these in reverse order. We know that water freezes at 0 Celsius because that's where we decided 0 Celsius was. In 1742, a Swede named Anders Celsius devised a temperature scale based on the freezing and boiling points of water. He gave his scale 100 divisions and he called it centigrade, which is Latin for 100 divisions. We'd still be using this exact scale today if he hadn't gotten it backwards. He put 0 at the boiling point and 100 at the freezing point, so the numbers got bigger as it got colder. Several other people independently invented the centigrade scale at about the same time or shortly afterwards. And they put 0 and 100 at freezing and boiling respectively, which is where they are today. Scientists used it for the next 200 years under the name centigrade, using the familiar degrees Celsius symbol, or the degree C. Non-scientists kept using Fahrenheit. The centigrade scale was renamed after Anders Celsius in 1948. And the reason they chose the guy who'd gotten it backwards is because his name started with C, and this way they didn't have to change the symbol. Okay, that's not actually true. Celsius was the first person to propose using a temperature scale based on physical properties of water. And in science, the rule is whoever gets to the idea first is the person whose name gets associated with it. Water freezes at 0 C because we defined 0 C to be the point at which water freezes. In 2019, the various metric temperature units were redefined based on unchanging physical constants instead of mere commonplace matter like water. But the new definitions were arranged so that none of the numbers involved actually changed. So from the point of view of the average person, you can still say that 0 degrees Celsius is defined as the point at which water freezes and largely be correct. How fast water freezes depends on the local conditions the water is experiencing. Going from liquid to solid is a phase transition, and this particular transition involves the water losing heat to pass from one phase to another. The speed of the freezing process depends on how quickly that heat leaves the water. If you take a glass of water and leave it outside on a night where the air temperature starts just above freezing and gradually dips below, that glass may not have finished freezing completely by morning. That same glass, poured into a vat of liquid nitrogen, will freeze almost instantly. The major factors affecting this process are the temperature difference between the water and the source of freezing, and how much of the water's surface is exposed to that source. Turning the water into a mist vastly increases the surface area, which means a mist will freeze ridiculously fast compared to the same volume of water sitting in a cup. There's another aspect to the question that I've kind of been dancing around, and that's how do we know it's freezing at 0 and not -1 or -2? The answer is that it is, but also that it's not. When something is going through a phase transition, its temperature doesn't change. When water freezes, it cools to, say, +5 degrees, 4, 3, 2, 1, 0, and then it stays at 0 until all of it is frozen. And then it cools to -1, -2, -3. This works the other way as well. Ice will warm up to 0 and then stay at 0 until it's completely melted. This is why ice cubes keep your drink cold for as long as the ice is present. That's the it is answer. The it's not answer is that everything I've just said is an oversimplification. In actual fact, things don't melt at one particular temperature, but rather over a range of 1 or 2 degrees. It's the kind of thing you only notice if you're sitting there with a thermometer watching it melt. There are a couple more points I want to bring up. I've been saying water freezes at 0 degrees, but that's only for pure water at the atmospheric pressure found at sea level. Changes in pressure will change the freezing point, but only by tiny amounts at the pressures you're likely to encounter. It's the kind of thing you can only see by finicky, pedantic measurements. Very high pressures will make very dramatic changes, but you don't see those outside of a lab. The more impressive change is what happens when something's dissolved in the water. Dissolved impurities drop the freezing point, and more stuff means a bigger drop. Basically, the water stays liquid at colder temperatures. When water is freezing, It's trying to form a nice organized crystal lattice, and having stuff floating around in the water that isn't water just gets in the way and stops that happening. So things have to be colder to freeze out all that other stuff there. This is how salt melts the snow and ice on roads. Frozen water has a tiny layer of melted water on the outside, and small amounts of salt dissolve in that, which encourages the ice next to the water to melt, and then the salt dissolves in that freshly melted water, which brings it into contact with the next layer of ice, and so on. Things other than salt work as well. Antifreeze is a small organic molecule that stops the water in a car's radiator from freezing in the winter. That's everything you ever wanted to know about how water freezes, and probably a bunch of stuff you didn't. Thanks for watching. I've been Steve.